Good day everyone, I am Aubrey Saludo, introducing our chosen topic, which is Lewis dot structure and its molecular geometry. Lewis dot structure is a diagram that represents balanced electrons of an atom within a molecule. It allows us to know how it will bond and how many bonds will it form. Lewis dot structure help us to visualize shape of a molecule and its chemical properties.
So this is the example of Lewis dot structure is CH3OH or methanol. Methanol is the simplest alcohol which has only one carbon atom according to the Lewis structure of methanol. It has one oxygen and hydrogen bond, 3 carbon and hydrogen bonds, and 1 carbon and oxygen bond. There are 2 lone pairs on oxygen atom. There are a total of 14 electrons in valence shell in the overall molecule as lone pairs and bonds. First you need to do is determine the number of valence electron in an atom. Remember that within any given column, all the elements have the same number of valence electrons to get the number. All we do is count the columns starting from the left of periodic table. Example is CH3OH or methanol. The rule for choosing your central atom is you use the least electronegative element, so that happens to be the carbon. Because carbon is less electronegative than oxygen, so we are going to put the carbon in the center. So now we have to count out the electrons and the electron pairs. To find out the total valence electrons given by the particular element in molecule or ion, you should multiply numbers of electrons of valence shell by the number of atoms of the element in respective molecule. Carbon has 4 valence electrons and oxygen has 6 valence electrons and hydrogen has 1 valence electrons. So we need to do is 4 of carbon valence electrons plus 6 valence electrons of oxygen and 1 valence electrons of hydrogen equals to 14 valence electrons, and 14 valence electrons divided by 2, you'll get the 7 electron pairs. Ngayon na, pag-decide na natin yung center ng atom natin, ay mag-sketch naman tayo ng CH3OH molecule. Lone pairs are marked on atoms. Remember that there are total of 7 electron pairs to mark on atoms as bonds and lone pairs. So, ngayon pairs na natin siya. 1, 2, 3, 4, 5. There are already 5 bonds in the above drawn the sketch. Now, only 2 electron pairs are remaining to mark on atoms. Usually, those remaining electron pairs should be started to mark on outside atoms, but hydrogen atoms cannot keep more than 2 electrons in its glass shell, and there is no possibility mark lone pairs furthermore or hydrogen atoms. Therefore, then mark remaining electron pairs on the oxygen atoms. Here and here. So now oxygen atom will take 2 lone pairs to fulfill fulfilled its octal. Now, all 2 lone pairs were marked on no more lone pairs to mark on carbon atoms. So, to mark the charges on atom, check the stability and minimize charges on atom by the converting lone pairs to bonds. So, there are no charges on one atoms. Therefore, we don't need to doing the step of reducing charges to get the most stable structure. Kaya ito na yung Lewis structure ng CH 3OH or methanol. Ngayon, dadako naman tayo sa molecular geometry.
Now that we have discussed the Lewis dot structure, we will now be moving on to the molecular geometry. Make sure you already know the Lewis dot structure in order to understand this topic better. Molecular geometry, also called as the molecular structure, is a three-dimensional structure or arrangement of atoms in a molecule. Understanding the molecular structure of a compound can help determine the polarity, reactivity, phase of matter, color, magnetism, as well as the biological activity. It is also usually called as the ball and stick model because its structure is literally just ball and stick, just like this example. Like I said kanina, it is important to learn and understand the Lewis dot structure first because mas mapapadali ang pagdedetermine natin sa shape or structure of a certain molecule. That being said, the Lewis dot structure and the molecular geometry usually go hand in hand. We also have different types of shapes for the molecular geometry. The shape of the molecule can be determined with the help of the VSEPR theory or the valence shell electron pair repulsion theory. This theory basically states that electron pairs will repel each other whether or not they are bond pairs or lone pairs, thus making them spread apart from each other to minimize repulsion. First, we have the linear shape. A molecule with 2 electron pairs and no lone pairs will have a linear shape, just like in this picture. On the other hand, a molecule with 2 terminal atoms and the lone pair of electrons will have a bent shape, just like in this picture naman. Other molecular shapes will be shown in this photo for you to have an idea on what they look like.
This is the molecular geometry of CH3OH, or called as methane. Methane has a central carbon atom, has 4 sigma bonds. 4. With 1 lone pair. And 1 number of oxygen with 104 degree, 104.5 degree event of hydrogen. And the angle bond of hydrogen to carbon atom is 109.5. form a bend shape around the carbon atom. It shows tetrahedral geometry with 3 hydrogen bond and 1 hydroxyl bond. On the other hand, around the oxygen, it shows a bent tetrahedral geometry with 1 carbon bond, 1 hydrogen, and 2 lone pairs.